Bismillahirrahmanirrahim. Dear students, online lectures, lecture number 2, part 1. I have already discussed the topic electric flux in details. I hope that you have gotten my all views, all point of views. Now, lecture number 2, part 1 is going onto the page. See in the summary form. If you face any problems, then you may contact through WhatsApp or email. It is electric flux. I have already said to you, electric flux is the magnitude of electric lines of forces in a specific area, or you can say electric flux is the dot product between electric field intensity and unit area. Flux is denoted by phi. A dot B is equal to AB cos theta, then you can write E dot delta A, E delta A cos theta. Phi is equal to E delta A cos theta. If you have to obtain the maximum flux, then angle between E and delta A should be 0 degree, and for the minimum flux, theta should be 90 degree. All these things already have been discussed in detail in the lecture number 2, part 1. Electric flux on a spherical surface. This is the mathematical formula. By using this formula, you can calculate electric flux on a spherical surface. Phi is the electric flux, Q is the charge which is placed on a spherical surface, and epsilon naught is the permittivity of free space, which is constant. You can write this value as this. After this, I have already discussed Gauss's law. There was two statements of Gauss's law. First statement was this: total electric flux always be equal to 1 over epsilon naught, the sum of total charges. And it is the mathematical another form. Another statement of Gauss's law is, you can write like this: phi is equal to phi 1, phi 2, and so on, plus and so on to phi n. And the second statement of Gauss's laws was, the total electric flux on the surface of irregular body or hypothetical surface always be equal to the sum of all fluxes of small spherical surfaces. And there was 3 application of Gauss's law. In application number 1, you have to calculate the electric field intensity on a large positive charge sheet. In this requirement, first of all, you have to calculate electric flux on the surface of cylindrical rod which is passing through this sheet in the same directions of electric field intensity. And you have calculated phi is equal to 2E delta A. After this step, you will go in Gauss's law. By using Gauss's law, electric flux on this charge sheet becomes phi is equal to sigma delta A over epsilon naught. And sigma is the total charge per unit area. Charge per unit area, charge becomes total charge area delta A, and charge density becomes sigma. Then total charge is equal to sigma delta A. And when you will compare these two values, then intensity becomes sigma over 2 epsilon naught, as you seen in this on the screen. Okay. It was the first application. Remember, all these information have been already discussed in detail on online lectures 2 part 1. And this was the application number 2 of Gauss's law. In this application, you have to calculate total electric field intensity of 2 charge sheets when they are placed in parallel. In this situation, you have 3 options. Number 1, when 2 charge sheets in which one is positive, another is negative, are placed in parallel. Can you see on the screen? Second option is when 2 charge sheets which are negative are placed in parallel. And third options are when 2 charge sheets are positive are placed in parallel. You can see on this screen. In the first option, when 2 charge sheets, one is positive, another is negative, are placed in parallel, and if you will calculate the total field intensity between the sheets, then it becomes sigma over epsilon naught. If I am asking, tell me the total electric field intensity at right hand side or left hand side of the sheets. The intensity will be 0. Right hand as well as at left hand side. When you will come on second option, when two charges which are negative are placed in parallel to each other, then the total electric field intensity between the sheets will be 0. Inside the sheets will be 0, and the right hand and at left hand will be same, which is equal to sigma over epsilon naught. Sigma over epsilon naught. It is the third option, in which two charge sheets which are placed in parallel and both are positive. And if you have to calculate total electric field intensity between the sheets, then it will be 0. And if you will calculate total intensity at right hand or left hand, then it will be same as negative charge sheets, means sigma over epsilon naught, sigma over epsilon naught. It was the second application of the Gauss's law. In the third application, in which you have to calculate electric field intensity on a spherical surface by using Gauss's law. Dear students, remember, these all informations have been already discussed in online lecture 2 part 1 in detail. I have given you these options in writing form, in summary form, short form. In this situation, in the first step, you will calculate the total electric flux on the spherical surface on which you have placed positive charges uniformly. The electric flux phi becomes E into 4 pi a square. 4 pi a square, a is the radius of a spherical body. 4 pi a square is the spherical surface area. In the second step, when you have used Gauss's law, then flux becomes 4 pi a square sigma over epsilon naught. After comparison these two results, you have obtained E is equal to sigma over epsilon naught. Sigma is equal to total charge over area, and area of a spherical surface is 4 pi a square. Dear students, on the basis of online lectures, lecture number 2 part 1, I have given you in detailed descriptions of electric flux, and in the part 2 I have given you the review in short form of lectures online number 2 part 1. If you faced any problem, you may discuss through WhatsApp or email. Okay, thank you very much, all the best.